Alright, we're going off of pretty much free power today. It's not going to be endless power because the durability of the components is taking into consideration, so endless is not a real thing, but pretty much free and very useful power that you don't have to mess with. Basically, we are working on the idea of spinning magnets past copper wires. When you spin a magnet past copper wires, it creates electricity. By doing this, we have a video about an alternator and an electric motor. This is basically showing that as long as you keep it pretty much to a 1-to-1 scaling, you can get yourself pretty much endless power, free power, with very little effort. If you have a lathe, you have a mill, you have fabrication abilities, you have access to any of this kind of stuff where you can actually machine out components, that's where you come in handy. You take the inner rotor of an alternator, you cut it all apart. Pull all the copper wires out of it, machine it all down, make it smooth. You're turning around and you're basically making this a magnetic rotor. Turn around, block out for neodymium magnets. Go north-south, all the way around it. Now you have a fully magnetic rotor. Fill it with epoxy so that everything stays in place and nothing goes flying out, because this kind of design, I can see a failure point being the magnets flying off. Definitely see that happening. Get it machined down, get everything to spec, reassemble. At this point, you do not need the actual regulator rectifier on the back of the alternator anymore. The windings and the magnets are the key principles. You tie into the 3 tie points on the windings that go around the outside of the rotor. 3 wires, 3 solder points, bridle, got it all together, wired up, you've got 3 power points. This is a capacitor. This capacitor is what takes any voltage spikes or anything like that. You really need to have one of those, especially on the charging side of your system. You've got a charging side, you've got a drive side. Everything's run together by a belt. That's your system. So basically what you're doing is you're putting magnets in place of the internal components of the motor. You're using a capacitor as a buffer for the electricity. Tie it all together, wire it up. Pretty simple wiring. And this is why it's not a perpetual motion device, because you actually have to pull start it. But once you pull start it, it stays running. He made a cool little bracket and everything, mounting plate. This is the way to do it. Give yourself a plate, a bracket, a way to keep the belt tight. And here is proof of concept. Pulls it, it gives voltage, and it was almost 200 volts. 230 volts. This is the second one. Here you go. Those are the motor specs. And it's the same deal. So he was getting 230 volts out of a modified alternator run by a secondary motor. He wired in the secondary motor. The secondary motor spun the alternator. All excess voltage from the alternator goes out to the system. This is where you can run your camping gear, your house, depending upon size. This one is a lot bigger, and it'll produce a lot more voltage. He goes in, he machines the rotor, puts the magnets in place. This is double magnets. He's got a lot more size, a lot more magnetism. The stronger you can make the magnetism, the more voltage you will get. Here you go with the epoxy again, because the epoxy is the thing that holds everything together. You have fun tearing it all apart. Looks all nice and pretty. Throw it on the lathe. Lathe it down to size. Reassemble. As you can see, all the coil wires are right around the inside of the motor, hugging the can. The com goes in the middle, so your fail points will be the brushes and the bearings. Not much you can do about that unless you make them self-lubricating or put some kind of lubrication system on there. Eventually they'll fail. Brushes will definitely fail after a while. It's a continuous rub point that they wear down. But you've got your high-powered magnets. You've got everything wired together. Put jumper bars across them. This is a lot bigger motor, so it's going to produce a lot more voltage. It's still going to be 230, but it's going to be a lot more amperage. Here you go. That's the way that the power goes. Nice little diagram. Capacitor wired in place. Again, you could probably use a capacitor like what you use in your stereo systems too. Just a buffer. That's all it is. Plugging it into a power source and showing you that, see, the motor still spins when it's powered. You got your drive motor, you've got your power motor or your generator. Tie them together, wire it up, bolt it down, get your belt tight. Look at that, he's got a bunch of wires plugged in. There you go, 10 kilowatts of power. Because of the size. Now, the weight of these flywheels will help the motors. Any kind of rotating mass that you can put on these will assist in them staying running. Weight is something that needs to be paid attention to. If you have too light of a rotor, it will not spin as freely and it'll be more apt to stalling out. You want to have enough weight to keep these things spinning so that they can easily work. Low friction, 230 volts AC, 10 kilowatts at 1400 RPMs. Start it with a drill. This is why it's not perpetual motion, because you're starting it with the energy of the drill. Once he gets it going, the generator powers the motor spins the generator. You have a continuous loop power system. 100%, and it works. It functions like it's supposed to. You can take a couple of these and probably run your house on them. This is not hard to find tech. This is very simple. Order the neodymium magnets. Find a machinist. Have them cut down the motors. If you have your own lathe or mill or anything, or ability to do this, you can do it at home in your garage. Really neat stuff. Magnets are the key. High-powered magnets, the stronger the magnets you can get, the better the system will be. Plain and simple. Hit that subscribe button. Let me know down in the comments below what you think about this. I'll see you in the next one. Have a great day.